Hey everybody, Mr. Mac here. We're going to go over 3.3 practice set, and really we're introducing some proofs here that we haven't quite seen yet. And a proof is an argument that takes a set of known facts or givens, and we provide several statements or reasons that allow us to get to the thing that we're trying to prove. So in a proof, we're always going to be provided with a given statement of facts. Occasionally we'll be given a drawing, but we usually have to make our own if we're not given it. And we're trying to find something. We're trying to prove something. So this is a two-column proof. We're going to put statements on the left and then the reasons why we can make those statements. And then we go from one logic statement to the next until we get to the final prove statement. So the first statement is almost always going to be the given. The last one's going to be the prove. So number 3, we are given that lines L and M are parallel. So let's update our drawing here. L and M are parallel. And the reason why we can write that in our proof here is it is given. Okay, we could have also put the other given, but it's gonna come down here. So corresponding angles postulate. So this is the reason. So this is the reason for what statement. We're giving you part of it here. So what angles are corresponding? So corresponding angles happen when we have a transversal that crosses parallel lines and then their angles are in the same relative position. So we can see angle 1 and angle 3 are in the same relative positions. These are corresponding angles right here, and they're going to be congruent. So we could say angle 1 is congruent to angle 3. So we're trying to prove that 1 and 2 are congruent, and this is our first step. We're going to show that angle 1 and 3 are congruent, corresponding angles postulate. Now, P is parallel to Q. So let's update our drawing with that. Do a double arrows here to indicate parallel. And we know this because it is given. Given as fact from the beginning statement here, the given statement. Now, next line, blank and blank. All right, so what these are parallel? What does that tell us? Well, that's going to tell us that angle 3 here and angle 2 are going to be congruent with each other. Why is that? Angle 3 is congruent to angle 2. Well, it's also because of the corresponding angles postulate. We have a transversal L crossing two parallel lines, and these are in the same relative position. These are corresponding angles. And the corresponding angles postulate says that they're going to be congruent. One is congruent to 2. So if angle 1 is congruent to angle 3, so let's see here. Angle 1 is congruent to angle 3, and angle 3 is congruent to angle 2. Angle 1 is going to be congruent to angle 2. So the best thing to use here would be the transitive property. This is the transitive property, which says if A equals B and B equals C, A equals C. You could also say that this is substitution. Use the substitution property. Transitive is better though. Okay. We haven't talked about the transitive property, but you have seen this in algebra, and we are going to be using that every now and then in here. Next one. All right, so we proved it. 1 is congruent to 2. Done. Number 4. Okay, we are given P is parallel to Q, angle 1 is congruent to angle 2, and we want to prove that angle L is congruent to angle M. All right? So first statement, P is parallel to Q. Let's show our arrows here, and that's given. This is just a puzzle. We're just puzzling out how we can get these statement of facts and then come to the understanding of the proof statement. Corresponding angles postulate. All right, let's see here. So 1 and 2 we know are going to be congruent. 1 and 3, can we show these are congruent here? We have this line L, which acts as a transversal across P and Q. Doesn't that mean that 1 and 3 are going to be congruent? Angle 1 is congruent to angle 3 because they correspond. Angle 1 is congruent to angle 2. Well, that's given. If you're not quite sure what it is, if you're looking at it, just check up here, make sure that maybe it's given to us. So that's easy. So 1 and 2 are congruent. Okay, so if angle 1 is congruent to angle 3, and angle 1 is congruent to angle 2, doesn't that mean that angle 2 is congruent to angle 3? Angle 2 is congruent to angle 3. Transitive property of congruency. This is property of congruency right here. All right, so now we've got these two are congruent. Now these are alternate interior angles. So if alternate interior angles are congruent, that means that the lines L and M, lines L and M are going to be parallel. And that's the converse of the alternate interior angles theorem. So that means that L is parallel to M. So the converse statement means we're reversing the if-then statement. So before we said if L and M are parallel, then alternate interior angles are congruent. Now we're saying if alternate interior angles are congruent, then lines L and M here are parallel. Okay, that's what a converse is. 5. Given angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4, prove that line L is parallel to line M. Okay, angle 1 is congruent to angle 2. Given. L is parallel to N. L is parallel to N. Well, this would be the converse of the alternate interior angle postulate. Okay, these are going to be parallel. So if alternate interior angles are congruent, then the lines are parallel. 3 is congruent to angle 4. Well, that's given. That's given. Do a double here, maybe. All right. Converse of alternate interior angles theorem. That is going to be these angles. 3 and 4 are alternate interior and they're congruent. Therefore, N, line N is parallel to line M. Right? And then lastly, so let's get that in here, doubles. So if L is parallel to N and N is parallel to M, then L is going to be parallel to M. So this looks like we could say transitive property. Transitive property works for congruency, but we did see something in this section called the parallel lines theorem. Which just basically says the same thing. If I have a set of parallel lines and I know L is parallel to N and N is parallel to M, then L is parallel to M. Pretty straightforward. Okay. Now, this next part right here is definitely requires some reliance on these theorems that we've been discussing. Because the drawing here is really wonky. This is not to scale. Not to scale. It is intentionally off to try to make you rely on these theorems that we've been talking about. So we want to use the information given here to determine which lines are parallel, if any. So angle LCD, so we're looking at this one right here, this angle here, is congruent to CJI, this here. So we're saying that these are congruent. Does that give us anything? So it would be as if we're saying we've got these two lines like this, and then this line crosses, and this one is congruent to this one. Is that saying anything? Are these alternate interior angles? No. This is interior, this is exterior. Or do they correspond? No. Or that would be either this and this or this and this. This is nothing right here. There's not same side interior, same side, nothing. This is none. There is nothing here that we can relate. All right. So maybe I'll just back up here, get rid of that, and this is none. Got to really mark this up. It's hard to see. Angle BCE is this angle here, and BAF is this angle here. Okay, so it's like we're saying this angle and this angle, these two right here, interior, same side of the transversal, and they're interior of the lines. They're supplementary. They add up to 180. So if same side interior angles are supplementary, does that give us any parallel lines? Yes. It means that these lines here are going to be parallel. So I'm referring to these right here, these lines. So let's name these lines. This is going to be line, how about AH? Line AH is parallel to line LE. For instance, I could also say CE or CJ or LJ, because the converse of the same side interior angles theorem. Abbreviating here. Everybody see that? All right. I guess I'll leave it. Different color, maybe. Angle FGH. FGH. So that's this angle here. Is congruent to EIJ. EIJ. This angle here. So we have this situation where we've got this is congruent to this. That's what we're showing here. Just redrawing it so you can see it. Well, this looks good, doesn't it? Which one of the five would this be? Same side interior, same side exterior? No. They're on the same side, but one's interior, one's exterior. Alternate interior, alternate exterior? No. They're both on the same side of the transversal. Well, they're both on the same, in the same relative position. This is corresponding. So this is going to be converse of the corresponding angles theorem. And it's going to be this and this line. So it's going to be this line here. How about GL? It's going to be parallel to KD. Line KD. Yep. 13. Let's get a different color here. BFH, angle BFH. We're talking about this one in here. And CEI is this one here. Okay, and we're saying they're congruent. So it's like we have this one. It's like this. Problem with this is there are two transversals here and not one. So we don't get a clear look at any one of these theorems for this. So this is none. That one doesn't work. Okay, let's try LBA, angle LBA. So this one going this way. And IHK. IHK, this one over here. So it's like we got that and just that. I mean, we don't even have a shared line here anywhere. There's no shared transversal. This one right here crosses and just totally misses. This one comes up and then intersects, but is not a part of any angle that we're looking at. LBA and IHK. It's just another none, isn't it? LBA and IHK. It's a none. So I gave you 3 nuns here. I'm surprised. I didn't think there were 3, but that doesn't work. Okay, angle ABG, ABG, and BGH. All right. I hope this one works. Let's get some mocha color on this one. Yeah. ABG is this angle. And BGH is this angle. This is looking really good. It kind of looks like this. Or we're saying this and this are congruent. Well, these are alternate interior angles, so we're going to get these lines parallel. So this is converse of alternate interior angles theorem. And it's going to be this line here. Let's go AB. Line AB is parallel to line GH. And that's a mess. Look at all this. I hope you could follow that. That's the hardest part of this section. We just did it. Now we're going to puzzle this measures 1 through 7. Let's get eggplant. No, let's get midnight. We got a bunch of parallel lines. We know this one is congruent here, and 107, 122. Okay. I don't care about filling this in order. Let's just start writing what we know. If I know this is 107, I know angle 2 is a linear pair. This has to be 73. Angle 3 is corresponding with 107. It's also same side interior with 73, so I could go this 2 different ways. It's going to get us 107. Let's see, what else do we know here? Well, I know that this angle here is 73. It's alternate interior with this. Let's take a look at this. This angle here. If this is 122, then these two angles are same side interior. They're going to be supplementary. So what plus 122 is 180? It's 58 degrees. Well, this is congruent to angle 1, so that means angle 1 is 58 degrees. So if angle 1 is 58 degrees, angle 4 is alternate interior. This is also 58 degrees. Let's see. We know that angle 3 is 107, and that means that this whole angle right here, this angle here, is also 107. These are corresponding. So I could say, okay, what plus 58 gives me 107? That's going to be 49. And then 7 and 5 are alternate interior, so 5 is going to be 49. Let's write them in. Angle 1 is 58. Angle 2, 73. Angle 3, 107. Angle 4 is 58. Angle 5 is 49. Angle 6. Oh, angle 6 I got to do. Angle 7 is 49. 6 is going to be, okay, so if this is 107, this angle is also 107. These are corresponding. And 6 and 107 are vertical angles. So 6 is going to be 107. There it is. That's that one. Now, the tricky part with this is getting the 58 degrees from this angle and then knowing that these are congruent. And, oh, is that it? I guess that's it. All right, well, it's getting more challenging. I totally get that. This requires a little bit more here. All right, I'll stop.